Standard 3.4 meets. I can calculate the velocity of an object in free fall and how far it has fallen given the acceleration and time of fall. The first thing that we need to know is that for free fall we have two separate equations that we can use. The first one, d is equal to 1/2 at squared. The second, vf equals vi plus at. I'm going to divide my paper in half so that we have space to work on both. For my distance equation, this is going to tell me how far it's fallen. First, I'm going to list my variables. D is what we're looking for. A is always 9.8 meters per second squared. And T, the problem tells us, is 2.9 seconds. Now for gravity or acceleration, we can use a negative 9.8 meters per second squared, right? What that's going to do is give us a negative distance. By calculating a negative distance, we understand that we're talking about the distance the object has fallen down, right? By using a positive 9.8, you're still giving me a distance, right? But in this situation, you would be measuring it from the ground up. Either way is correct as long as you're understanding whether the object is falling down or moving up. Now, let's calculate for D. D is equal to 1/2 negative 9.8 meters per second squared times 2.9 seconds. This 2.9 seconds is squared, and so we're going to start with that. Always take 2.9 times 2.9, or whatever your time is. You want to make sure that you're squaring that first. Then multiply it by your 9.8, then multiply it by 0.5. Remember that multiplying by 0.5 is the same thing as dividing something by 2. If I plug all this into my calculator in the correct order, I get a negative 41.209 meters. Now again, if you had not plugged in a negative 9.8, you'd end up getting a 41.209. Either is correct as long as you understand that distance in this situation, if the object is dropped, it's fallen a distance from the top to the bottom. Now let's look at the second equation. The second equation is going to help us solve for the speed, right? And that's because we're solving for VF here, whereas before, when we solve for how far it's fallen, right, that's a distance, which is why we use the other equation. Now, let's list our variables for the second equation here. VF is what we're looking for. VI is 0 meters per second. Because when you drop something, right before you drop it, it always starts out at 0 meters per second. A, 9.8 meters per second squared. Again, if we want to plug in a negative here, that's going to give us a negative speed, which makes sense if the object is falling down. Last but not least, we have T, which the problem gives to us as 2.9 seconds. Now let's plug some information in. VF is equal to 0 meters per second plus a negative 9.8 meters per second squared times 2.9 seconds. When I plug this into my calculator for VF, I get a total of negative 28.42 meters per second. Make sure you have your right units on any answers that you provide.